Mm. Hi everyone, this is Tushar and my teammates Gautami, Mahipal, Ramandeep and Vivek here to present the project demonstration on IoT enabled smart waste management system for sustained urban living. And project scope is discussed by Ramandeep. Over to you, Raman.
The main objectives of the project is that we have to install the IoT sensors in the garbage cans so that we can track the filling level of the trash cans, and also we have to improve the collection routes through which vans are going to collect the garbage waste in the city. And we by this we can reduce the waste and improve the urban sustainability. The main deliverables of this project management is that we have to install hardware such as smart containers and IoT sensors. And in software, we have to give user interface analytics and navigation planning. And we have to integrate the IoT devices with the central system. And we have to choose the city for the experiment. And in this instruction, we can document all the project. And in this there are milestones such as startups, organizations, and hardware communication. It all takes 8 weeks to complete, but the most of the major of the time taken by the software engineers to complete that project. And in this, we have integration and testing, pilot program execution, instruction and records, and assessment and improvement, finalization of implementation, and project termination. All these milestones took about 72 weeks to complete, which is about 1.5 year. And the limitation of this project management is budget constraint. We have limited resources and technical resources such as connectivity and compatibility of the IoT devices. And we have also limited promoters. So we have limited assistance by the government. Next slide. And we have some of the stakeholders that are affected by this project, such as local authorities, such as high interest and high influence, which have, and most of them are waste management organization, and the residents that are affected by this project, and most of them are technology providers. So this is the main work breakdown structure of the smart waste management, which have about 11 uh, uh, 10 major tasks, and there are also subtasks in this which can be which are which are the next slide is given to.
Hi guys, myself Vivek, and this is a WPS implementation of schedule, task, activity, and subtask. And this is the diagram of the project of WPS implementation of schedule. And the analysis of the cost. The entire budget of the project is 27 lakhs 85 850, and the planning is $24,300, and for the hardware is 6 lakhs $23,600. For the software development is 6 lakhs $17,600, and the project score is 9,650. Throughout the budget, coverage of guidelines, efficiency, advancement throughout every phase of the project. uh, Resource plan. The human resources for the manager is $100 standard, and $150 per hour overtime, and IoT engineer $80 standard, and $112.50 per hour overtime. For the data analyst, $70 per hour standard, and $105 per hour overtime. And financial It's $75 per hour standard and $112.50 hour for overtime. And this is our picture of overview. And the next for the Gautami.
Hello everyone, myself Gautami. Now I am explaining the material resources which we used in our project, like smart bins, which cost us $300k, and like risk mitigation cost us $200k, and these are all the resources which we included in our project. And this is the next slide, please. This is the overview of Gantt chart. It shows the 75-week timetable for the smart waste management project, including phases, deadlines, dates, costs, resources, and completion dates of each assignment. And the next slide. This is the overview of the network diagram, which helps to identification of crucial routes and the detection of scheduling problems, and by visualizing task relationships with nodes and arrows. Thank you.
Yeah, coming to this slide, here we'll be discussing on the concurrent development of parallel activities performed during the project development. And here we consider hardware acquisition and software development as parallel activities. And here we can see in the picture, respective Gantt chart shows the critical path with the orange color, and blue color is not included in the critical path. And the respective WBS implementation is present in the picture. And coming to critical path, as I discussed in the previous slide, it is the longest path that project can have, longest duration that a project can have during the project closure. And we can see the critical path is this way, rather this, because when we consider this as a critical path, it has 63 weeks, but when we consider this as a critical path, it's 67 weeks. So the longest path will be the critical path, and this critical path is used for project crashing. And the assumptions for this project crashing is to reduce the duration by 10% as proposed in the project um, requirement. And to achieve this, we are adding the additional resources to shorten the time frame. And this is also increasing the overall cost of the project. And this table demonstrate the original duration and the crash duration with the incremental cost of each task with the cumulative crash task. Here, cumulative crash task will add up all the incremental crash stop, and this is what the extended or more cost that we'll be including to crash the project by uh, 10%. And the total cost of our project was uh, uh, 2.7 million before crashing, but due to crashing, 229k is added to the project budget, which results in 2.9 million. And the total duration before crashing was 67 weeks, as discussed in the critical path. And after crashing, the total duration will reach up to 60.3 weeks, which is 10% of 60, which is 90% of 67 weeks. Over to you, Mahipal.
Yep. Thank you, Tusha. Hi, this is Mahipal. Uh, I'm here to explain about the risk management which is involved in our project. Coming to risk management, which it is includes identifying and magnitude to risks such as IoT device failures, data security breaches, and stakeholders opposition. Uh, the other one is risk matrix. In this, we can see that there are few risk categories that which involved. One is technical, and then operational, then environmental, and the other one is financial and legal. Uh, There is risk description and likelihood, impact, risk levels, and risk strategy, which involve for every risk categories. And the next is uh, coming to this ethical issues. There are few ethical issues in our project. One is accountability, respect, fairness, and honesty. And ICT service management analysis, stat, uh, strategic alignment, robust design, most transitions, reliable operations, and continual improvement. Then the other next slide is coming to conclusion. The goal of IoT enable smart waste management system to improve the sustainability of urban living for more intelligent and environmentally friendly future. And the project overcomes obstacles with reduces risk and guarantees ethical and successful execution via careful planning, stakeholders participation, and efficient resource management. And thank you guys. This is our project.
Thank you.
Over to you, Tusha.
Thank you.